So tomorrow in class, we're going to be doing our first experiment where we carefully think about what's the independent variable and what's the dependent variable. Everyone's going to be doing a kind of similar experiment, but you're going to be using different balls. We've talked about this before, how if you drop a ball, it will bounce not quite as high as you dropped it from. So we're going to use the drop height of the ball as the independent variable. You're going to choose specific drop heights, and then you're going to measure as the dependent variable the bounce height. So for example, if I wanted to choose the drop height of 1 meter, I would make sure that the bottom of the ball is at 1 meter. I would drop it and say, okay, it looks like it bounced to about 0.6 meters or so. If I chose the drop height of 0.6 meters, I could say, okay, drop height is 6 meters, drop it and say, it looks like it bounced up to about 0.35 meters. So again, I'm choosing specific values for drop height, and then I measure the bounce height as the dependent variable. This is a little tricky to do because, as you'll see, when the ball moves up, it's a little bit hard to see exactly where the ball bounces to. My only clue that you'll need to keep in mind is we're always going to be measuring from the bottom of the ball. The idea is when the ball is sitting on the ground, it is the bottom of the ball that's at 0 height. So we're using the bottom of the ball as our point that we're measuring from. You're going to have to figure out exactly which values to choose for your independent variable of the drop height, and you're going to have to measure each drop height a few times because you'll see it's not exactly the same every single time. So now that you have some idea of how this experiment is going to work, tomorrow we're going to take some notes in general about how to think about independent variables. In a scientific experiment, a research question can often be stated in a form such as, what is the effect of the independent variable on the dependent variable? So for example, in the experiment that we're doing tomorrow, where the independent variable is the drop height and the dependent variable was the bounce height, we could say independent variable is the drop height, whoops, D-R-O-P, height, and the dependent variable is the bounce height. The research question could say, what is the effect of drop height on bounce height for a ball? That is, the effect of drop height on bounce height is going to be different depending on what ball you choose. So the research question is something that helps us investigate this relationship between the drop height and the bounce height. So in general, the independent variable is the thing that the scientist, whoever is doing the experiment, the scientist chooses to change. And as you remember from class, factors held constant are called controlled variables. In order to see the effect of the independent variable, I'm gonna change this. I'm gonna say, in order to see the effect of the one independent variable, all other variables must be controlled. That is, held constant. So this is an example of one research question. What is the effect of drop height on bounce height? I wanted to show you another example of this from Fatimata Kandi's work in second period. These aren't actually experiments that we've done in class, but these are experiments that we could imagine being done. For example, what is the effect of vinegar on cucumbers? I would say we would want to actually identify something that we could put a number to here. So for example, what is the effect of the amount of vinegar on the size of the cucumber, or something that is like something that we can put a number to. Just saying vinegar isn't specific enough, but I could imagine a really good experiment being done this way. Or what is the effect of high temperatures on humans? Again, we would want to put a number here, for example, the human's body temperature, or something that we could identify as a number, something that we can actually measure. Let me also show you Anya's work from third period. She identified this as a research question, and it definitely is a question. Can we find the amount of force exerted on the noodles? The answer is definitely yes, we can. But what makes a research question special is that it has the independent variable and the dependent variable in there. So for example, in this question, the amount of force exerted on the noodles, that is just one of those variables. The research question actually identifies both, not just one. Lastly, I want to identify Triana's work. She identified a research question that we definitely have done in class. What is the effect of the number of noodles on the force exerted by the scale? The independent variable is the number of noodles, and the force exerted by the scale is the dependent variable. So really nice work with those three examples. We're going to look down at EA2 and do this real quickly. EA2 is about the difference between a variable name and the unit of measurement for that variable. We write all numbers with a unit that fits the measurement. Be careful not to mix up a variable name with its unit. This is a very common mistake, so we want to clarify which is which. The variable name and the unit are two very different ideas. And if we look back at Fatumata's work, we have some nice examples of the difference between them. So for example, F earth on object is example of a variable name, and F earth on object is measured in units of newtons. So I'd like to actually include this as an example in our notes. F earth on object is measured in newtons. That is, this is the variable name, and this is the unit. Another example that I really like that Fatumata came up with, which is something that we haven't talked about much in class, is time can be measured in units of minutes. So I'll write time, which is the variable name, is measured in minutes. Now the interesting thing here is time could also be measured in seconds or hours or years or centuries. So minutes or seconds both work as a unit for the variable name. Now if we're being specific about the variable name, we can't just use the unit. We need to say specifically the name of the variable. Just like if we're referring to a specific force, we need to use that name rather than just saying like, hey, what's the newtons? That's not nearly as useful as saying, what's the force exerted by the object? Lastly, I wanted to give an example of something that we'll actually use as a variable in tomorrow's lab. For example, the drop height. Remember, we're going to be dropping those different types of balls from various different drop heights that we choose. The drop height is measured in units of either meters or centimeters. Technically, we could measure drop height in units of inches or feet. We're not going to do that tomorrow. We're going to use the metric system. But all of these are examples of the difference between a variable name and a unit. This difference will be very, very, very important as we go on. So, big star here. Do not mix up a variable name with the unit. It says that up here, but this is so important. This is such a common mistake. I'm telling you again down here.